Hey everyone, welcome to SOLIDWORKS Live Design on this beautiful Friday. I hope the weather where you're at is as nice as it is here. We got a good one today. SOLIDWORKS Live Design, it's a series that we run here at SOLIDWORKS that is dedicated to the pursuit of learning from one another and using this medium of live demo and exploration as we go through and share some of our favorite tips and tricks, getting into the software, whether that's CAD or today we're talking rendering. It's a great place to tune in. So make sure to like and subscribe if you're new here. If you're a returning customer, Eric, good to see you as always. We appreciate you tuning in today. My name is Mike Sandy, and today we're joined with Jesse Sprague. Jesse is an industry process consultant here at Dassault Systems on the SOLIDWORKS team. And he's a member of our technical marketing team. As most relevant to our topic today, he's the creator. If you ever log in and turn on your SOLIDWORKS and see that splash screen, Jesse's actually created a ton of those iconic images that you see when that splash screen comes up, both for the CAD package and within Visualize. And he's going to share some of his amazing knowledge with us today. Now, Jesse, before we get into the actual content, over the next 60 seconds or so, can you tell us a little bit about the episode today, including some of the three main topics that we're going to talk about on live design?
Yeah, definitely. Good to see you, Mike. So today I wanted to focus mostly on the appearance side of things, focusing around specifically the DSPBR format, which was a fairly new switch in Visualize last year. This is good information, though, even if you're not a Visualize user yet. Hopefully after the episode you will be. But this whole system is kind of going across the board. So this is something that you'll see in other products. SOLIDWORKS users will be getting this system as well. So this will be good information really for anybody, whether you're a Visualize user or not. But yeah, we're going to focus around that DSPBR format. So first we'll talk about what that is if you're unfamiliar with what it is. And then we'll go into kind of the basics of working with that system, and then sort of, I'll say in air quotes, a more advanced way of working with that system, and really the way that you would normally work with it and how to take advantage of the power that it has.
Yeah, that's awesome. You and I could talk about this stuff. We were joking earlier for hours on end because it is very fascinating.
We still might. We're in the episode now.
We're going to do our best to keep it in our time constraints. So let's dive in. Let's go into that first topic. You mentioned, what is the DSPBR appearance? And for those out there, PBR is kind of the standard. And no, it's not the Pabst Blue Ribbon that we hear about. Jesse, can you kind of dive in a little bit more about what is it?
Yeah, definitely. So the PBR appearance, I guess probably it makes sense to take a step back maybe from what the PBR appearance is and talk about what the problem is that we're trying to solve with a PBR appearance. And I think, like, you've got some of the brightest minds in the world saying things like the world has far more variation in it than we realize. Not the brightest minds. That's just me saying that. But it is actually true, though. The eye that I have in the back of my screen there is a perfect example of this. It's what we use to kind of like look around the world and observe the world. But when you ask somebody what color is their eye, they say it's blue, it's green, it's brown, or whatever, right? And that's a massive oversimplification of what is actually going on in the eyeball, right? If we look at, this is not the sharpest image, but good enough to explain what we're talking about here, right? We've got probably millions of colors in an eyeball. We've got all sorts of contrast. It's fairly random. There's little blotches of colors here, there, and everywhere. And that concept really applies to everything in the world that we look at, right? We say the road is black, a tree is green. If you actually rendered those things as an eyeball is blue and a tree is green and a road is black, it would look pretty terrible, actually, because you're really oversimplifying everything to a point where it's not even remotely close to realistic. Probably that is the main stumbling block. And Mike, you will likely agree with me that people will bring stuff into a rendering software, any rendering software, and they'll say, okay, well, just bring it in, hit render. Doesn't really look realistic at all. The downside is that our eyes are very tuned to recognizing all of that detail that we always see in life. We can pick up that something is not right at all, but there's some weird disconnect between this doesn't look right and I don't know what to do to fix that. Right? There's always that weird connect of, okay, how do I make it look realistic? There's no realistic button in the software, right? That's ray tracing. So the disconnect is that it is looking realistic, but it's not looking realistic to the way that we normally see things in life. So that's really what a PBR appearance aims to fix. We're adding in more detail to the models that we're creating, right? So if we think about something really simple, and I tried really hard to simplify this as we're talking about it today. Take just a sphere, right? If we have something that is a sphere, we've modeled this sphere, it took us forever in SolidWorks, right? And then we import it into Visualize and we hit render, really doesn't look that impressive at all, right? It's just a gray blob. A PBR, which is a physical based rendering setup, will allow us to take more information and overlay that on the model that we've already created. So we're building detail into the model itself, but just the visual detail. So for example, this PBR appearance that I have set up here is a set of maps, and we'll talk about how the maps actually work, but a set of maps which are nothing more than just images. We're overlaying that onto the model itself. So this is still exactly the same model. It's just a smooth sphere, but we're taking a bunch of visual information and overlaying that onto the model. And it's our only way really to tell the shader and tell the rendering system, I know this is just a smooth sphere, but this is what it should look like in real life. Like when I look at this with my eye in real life, this is what it would look like. All of that information is baked into the appearance format. So you can see that all of this color information is widely varied compared to just one single color that might have come in from SolidWorks.
And Jesse, I want to just point out too, for those in the audience that might be new or newer to rendering, one of the terms that you're going to hear often, and whether it's in our software or it's in the gaming world or CGI and animations, is maps, right? You commonly hear that. It's a term you see out there. So really what Jesse is saying here is that we have different ways to map these, and he'll get into the PBR side. So just be aware that map term is just a common term, technical term that we use for exactly what Jesse's showing. And this is so cool already. So sorry to keep going, but I want to make sure everyone's aware, that's what a map means.
Yeah, no, and that's true, because that is another, maybe barrier of entry to rendering, is that there's a lot of lingo that's standard lingo. One of the best things about the PBR appearance is that it's pretty industry standard compatible. But there is a lot of lingo that we would not necessarily know as CAD users that applies to rendering. So it is good to pick up those terms along the way. Again, just to reiterate those maps, they're just images, like just a JPEG image. Really nothing more than that. It's just got information in it. When we get to the third section, we can talk about, what exactly those maps do in combination, but a set of images essentially that are doing the work for us, right? So this is kind of the basis of it. We're taking all of that visual information. It's our translation to tell the rendering software, this is what it should look like in real life. And that can be a variety of things. We'll take a look at the maps themselves in just a little bit. But again, that's the basis of it. It's just a translation tool where we describe to the shader what it should and supposed to look like in real life. And we have the opportunity to add a whole lot more data than we would be able to by just saying it's one single color.
That's really cool.
Yeah. So let's move on to the second point, which is, what do we actually do with this thing once we figure out how to get there? So my second point is just the basic setup of a PBR system. The fine folks at Visualize have done a really good job at simplifying this. I'll mention this as one of the things that I really love about the way that we've implemented this. And that is that they've kind of grouped things into bins. The whole entire system can be very overwhelming. There are a ton of parameters that we could potentially define for the way that things look. Good to have all of that power, but if it's your first time using it, can get very overwhelming. So you'll find that in the software, everything is grouped together in sort of bins that are pretty easy to use. So I have just a screenshot, and we'll jump into the software in just a second to kind of mess with these. But they have these kind of set up in terms of what are the things that you're commonly using. So on this slide here, you see these sort of rows that go across. These are things that we can control that will control the way that the appearance itself is rendered by the software. So the way that something looks when we go to render things is basically a combination of two things: the lighting that we have applied to it and all of these properties that we're setting. It's really the combination of those two things that's the main driver of what our end result is going to look like. So what we want to do is sync those settings up to what it is we have in our head that we want the scene to look like. What type of environment is it in? And what does that individual appearance look like? Let's just jump over to the software, and we can just start right from scratch here. So I'll just bump over to Visualize, which I have open, just a new project, nothing going on in here. If you've never seen the interface of Visualize, it's laid out pretty nicely. Off to this left-hand side, we have just a set of tabs that will control, again, sort of in groups, the things that we would need to do in the software. And then this is just our graphic stage in the middle where we get to do all of our work.
Hey, Jesse, before you dive into this section here, I want to, so there was a change in Visualize at some point. You showed that last screen that had some of the new terminology like albedo. What do you remember when that happened? Was that was last year, this year? So
right,
for users that are on older versions.
That came in last year.
Okay.
So if you're using previous versions, or if you had set things up in previous versions of the software and then you open it in the 24 release, you'll see a little message that pops up that says, hey, you're using legacy appearances. Do you want them to convert them over to the new one? And there's a little system that will do that conversion for you. So if you want to make use of the new one, or if you're using the current version of the software, the whole library has already been converted. So the ones that are in there are already set up with this method. So you don't have to do anything other than just use the appearances like you have been.
And we could still do more complex appearances in old Visualize, correct? That's not it's just the new layering method is what with the what's new, I guess, for last year was. Is that
right? Yeah, it's really just a format switch. And I think one of the things that I've been seeing around the web, and one of the things maybe that prompted me to do this, is the thought that, okay, well, there's a new appearance format. It's just going to look better than the old one. That would be the reason for switching, which isn't really the reason for switching. In fact, the appearances that are in there are actually tuned pretty close to what was in there. So the goal was actually more so to not notice a difference in switching formats, but suddenly you've got a lot more power and convenience underneath there to work with, more so than, oh, this appearance that I was using in the old format suddenly looks a lot better than, now that we have a new format.
Got it. Okay.
Yep. So let's just pop in some geometry. We'll just, start with our sphere that we were already using. Visualize does have some primitives. Normally, you're not doing any kind of modeling from within Visualize. Just as a reminder, you're always importing things from SOLIDWORKS. But for the sake of example, you can use, planes and spheres and things like that. So I'm just going to drop in a sphere so we can, work with a simplified example because we only have limited time here. So I'm going to put this in to kind of match up what we had on our PowerPoint. I am already in ray tracing mode, which we could see from the top here. So I'm already rendering this. And again, we get the exact situation that's on the slide that I had before. Just kind of looks like a gray blob of clay, nothing really exciting to report. So to work with the appearances, of course, from our library tab, we have access to all of the assets that are available that ship with Visualize. So from within here, you have, your environments and appearances and all of that stuff, backplates and so on. From the appearances section here, you'll see the whole library. And again, as I just mentioned, this has been converted. So all of these are the new format. One thing that I'll add in here as a reminder, though, at the top, there is an option here for the cloud system. If you toggle this over, you may find other additional appearances in here that you didn't realize that you had. So always a good idea if you're looking for something and you can't find it, these are searchable. If you're looking for something in there and you can't find it, try looking in the cloud, because it may be an appearance that we already offer and ship. It just didn't download, right? The whole full package is large in size. So you can toggle that over and look for more appearances than you might already have installed locally on your machine. So this would be the whole layout. And of course, you can see that they're organized by types of materials. That'll be important in a moment, but you can use these drop downs to find any kind of material that you might be looking for, right? So the kind of standard things that you would be using on a day-to-day basis, they've tried to put those in the system and convert those over. But you can, again, look for more on the cloud. Now, I'm not going to bother applying a preset one here because I actually want to go right back to appearances.
Yeah, and I'll while you kick over here, I wanted to just point out, years and years ago, I remember having a conversation with some of the product managers for Visualize about the library. And really their take on it was, we could create and roll out an extensive library, a lot of time, effort, cost to do that. But what they found is that within mechanical design, mechanical engineering, they fine tune that to have the most commonly used appearances off the shelf. And then they put the effort into being able to create on the fly custom appearances to match what your company needs and requirements are and what they do. So if you actually go back and look at some of the recent releases, like color swatches, being able to use the color picker from, another application, a lot of those are intended to really streamline the process for the end user to build up a custom library for the materials that you're using on the fly versus like us just trying to figure out, us being, SolidWorks, trying to figure out what you are going to need. So why I bring this up is it's really important. If you're digging through that standard library, you're like, they don't have what I need. You can grab something, to start with that's pretty close. And you'll see Jesse's going to go through and talk about how you can customize that or build it from scratch. So just be aware, like it's really easy to build your custom library to your colors, your swatches, your branding as needed. All right, back at it, Jesse.
Yeah, absolutely. No, and that's actually a great segue because I think with one of the benefits of the DSPVR after that switch, these are even more tunable and way easier to use, especially with if you're getting appearances from somewhere else or, buying or downloading things, they're even more compatible with those. I actually very rarely save my appearances anymore because it's so fast and easy to just create them on the fly. I'm almost always kind of tuning and tweaking things anyway. Once you get used to this system, of course, you're welcome to save them if you want to, right? We can always just save appearances right out from the top. So you can save them if it's exactly the way that you want.
And share them.
Yeah. Right. And share them. Right. Yeah. You and I share appearances back and forth all the time when we're working on projects. So that is a great use case for that. But when I'm just personally working on my own, they're so easy to customize that I have a tendency to just make them as I go. Obviously not for every single appearance that's in there, right? We use kind of default ones, and then the ones that stand out, you go tweak them. But that is one of my favorite things about the DSPBR switch is that it's very flexible. So in looking at this, I've just, while Mike was talking there, I just right clicked in here and I said new appearance. So we've created a new one completely from scratch. So no preset anything in here. You'll see that we have the opportunity to give it a name. And of course, by the way, there's 3 tabs across here at the texture. We'll get into this more in a moment, but we're on just the general tab for information here. So this layout that we have is with the appearance type set to basic. So this is basically just like a greatest hits. The things that you use on probably the most regular basis are the options that you're seeing shown here. So we've got this kind of listing of these typical things that we're using, and you'll see how these kind of line up with the maps in just a moment. But in terms of basics, because that's the section that we're in right here, you'll see that we've got albedo at the top. This is probably the most confusing new term that you might know. Albedo is the diffuse portion of the shader. Those words are kind of used interchangeably. That's just the color data. That's purely color data. So if you took all of the lighting and stuff out of it, just what color something is what that albedo setting is.
And so if you Google it, the first hit, and I've got it up here, is from NASA, right? The top hit is the my NASA.datas, and they basically say the fraction of light of a surface it reflects. So they're just looking at that total wavelength, what's kicking back. If you simplify that down, what color is it?
Yeah, exactly. And it is.
So didn't make that up. That is a common scientific term. I've seen that out there. Like, why did you just call it this? Well, probably should have, but in the scientific world, that is the correct term of it. So
yeah, and even across the rendering world, this is very common.
Yeah.
So that term would probably not be familiar to you as a SolidWorks user. But if you're into the rendering space, you've probably seen this. And to be honest, most of the time it's listed as albedo/diffuse or something like that. Many times when you're downloading maps, it's just listed as diffuse, but it's exactly the same thing, right? So it's just purely the color data. So if we were to apply this new appearance that we just made on there, and I changed the color of this, you'll see that changes the albedo or just the diffuse portion of that. So now you're saying, okay, well, there's, the color is actually changing. It's not one single color, like I said before. Again, that's because we're in our rendering environment already. So the the environment that we have surrounding it, if we go to the scenes tab, we have an HDR lighting environment that is spherically mapped around here. That's shining onto the object itself. So the appearance is already now automatically interacting with the environment that we have it in. And these settings are a combination, or this information is now a combination on screen of what the lighting is doing and also what we're setting as the settings in here. So for example, if we change the roughness, that's an easy one to see. We can make this more shiny, so to speak, right? We can see our reflections more clearly in here. If we didn't want our reflections so visible, maybe we could, muddy those out or fuzzy them out a little bit by increasing the roughness. And now those start to soften up, right? We're diffusing the reflections by just making the surface of the appearance a little bit more rough.
I was thinking this like 100 grit, 200 grit, 800 grit, 1600 grit as you're going right to left and just getting that polish. And to me, roughness is probably an area where people who are new to rendering, when I see their stuff, hey, Mike, take a look at this. What do you think? I'm like, oh man, just play with that roughness a little bit. It's either usually way too shiny or way too rough, fine tuning that. And Jesse, honestly, between the two you just showed, you're going to get a long way with refining your final renders.
I totally agree.
So
I totally agree. Yeah. And it may be a combination of the top three. This metallic also has a slider here as well. This is slightly misleading because metallic is really an on or off. Either a material is metallic or it's dielectric. It's one or the other. So generally with this one, you would want this to be all the way off or all the way on. So you would go one way or the other. So if I slide this all the way to on, now this starts to look like, a chrome ball that's been sanded.
That's cool.
Yeah, so it's kind of an on or off. The reason why there is an in-betweeny here, and it's not just a checkbox, is because there are situations that do warrant that. Most of the time, I'll say you'll be doing this with a map, which we'll get to in just a second. But you could have a case where you have a metal that has maybe something over the top that's semi-transparent, like a metal with dust on it, might be somewhere in between in spots because the dust is dielectric, the underneath is metallic. So it's some combination of that you're kind of seeing come through. But really, that would be the only time that you would go in between on a metallic. And again, usually that's driven by a map that in specific locations. So that one in particular.
Hey Jesse, we got another rendering champion in the crowd here, Alex, who's wondering on processes or anything you might want to mention. We could do this towards the end as well on matching Pantone colors. I know that's always a common question that comes up with customers.
Suggestions for matching Pantone colors. I do have some suggestions, and we can hit that right now because we're talking about albedo. So matching is super, super simple in Visualize for a couple of reasons. One, Mike, you just mentioned actually both of them. We have this swatches upgrade that we got in 2023. This has the ability to create and save these swatches in here, and you can also import them. So you can download swatches from on the web, and a lot of times you can get those down in a format that you can bring in, like a CSS file. You can import that, or you can bring in Adobe swatch formats. So if you have those colors in some format of swatches that you can export, chances are you can bring it in here, or you can find an intermediate that will work. I was just recently using CSS files just last week, and that works great. So you can bring those in and make use of those by just directly importing them, and then you've got the colors to choose from right from here.
Cool.
Secondary, Mike, you also just mentioned that we have the color picker. The color picker picks from anywhere, also within the same update in 2023. So if you have your web browser open and you've got searched up the color for Pantone that you're looking for, you can just, cruise on over to your web browser. It will pick that color up from your web browser, and then you're on your way. You're ready to go.
And for those that Pantone also it's a licensing structure. So Pantone is a company for profit. So if you want to learn more, you can always visit Pantone.com and kind of go through their EULA, their process, their products that they offer to be able to get those.
Yes. Thirdly, I guess I'll mention, if you move over to your color tab and hit the drop down, I tend to work in HSV mode, which allows you to adjust your hue, your saturation, and your value that also opens up the hex code. So if you have the color code, you can also just paste that in from anywhere and make use of that. So that's a convenient way to do it too.
Yeah, those are really good for like if you have a corporate branding as well. So if your company like Dassault, we have a bunch of different brands, they all have different colors. When we're creating renderings or working with customers, we make sure to get their exact their hex codes or whatever they want to supply and create the exact color match inside of Visualize. So when we do the render, we're making sure we're matching branding from those elements.
Yeah, exactly right. I was just doing that this week specifically for the What's New content, which you can all look forward to soon. Yeah, so that's a great way to do that. Usually where that goes wrong, if you've done all of those steps and you say, okay, well, I put in the right color and it doesn't look right when I render it, chances are what's happened is remember that this, your graphics area and what ultimately gets rendered is a combination of the inputs that you're putting in for the appearances. And also it's a combination of the lighting that you have applied. So for example, if you were using an environment that had very colored lighting, that's going to impact what's going on in here. So looking through these environments that we have, these HDR lighting environments, if you were using something like a fall street or, a dark sunlight or something like that, that has a lot of color in the HDR, that's probably what's happening. It's combining the color of the lighting in with the color that the appearance is, and those two mixing are resulting in a color that doesn't look right to you because you have it out in the middle of a field instead of in a photo studio or something like that. That's usually the disconnect if you've got all the other stuff right.
Right.
But yeah, good question. Okay, so again, this is the basic format for this. So if we hit this little drop down, there are more options in here. And you can see, I mentioned earlier that they have all of these categorized. So when you're using an appearance from the library, it's already preset to the type of appearance that you're using. If you drag in a metal, it's going to be preset to working with a metal-like appearance. So you can see that the presets, the subtypes are listed in here already. So if you were creating an appearance from scratch, you could make use of these subtypes that they've already built in for you, which is really nice. The reason why that's really nice is if you look at this top one here, this enterprise PBR shading model, this is everything that the shading model has to offer as far as what you can tweak to make things look the way that you want to look. So once we open that up, you can see this is a very extensive list of parameters that you can tweak to change the way that your model looks as it gets rendered. So this is the full description that we're providing the rendering engine as to how this appearance looks. So if you were to just start here, that would be very overwhelming, right? You would have to know which ones of these settings do I need to use to make it look the way that I want it to look.
Yeah, and it's pretty rare to need that complex of a material.
Yes.
Yeah.
Yes, absolutely. So that kind of leads us to, that we've got this grouping. So that gets preset for us. That's really nice. And what I normally do is simplify this list with the type of the subtype of appearance that I'm using, and then increase complexity by making use of all of these little plus marks here. So that leads us right into our third topic, as you just saw, which is increasing the complexity by using the available slots to add in maps. So I'm going to jump back to my presentation here real quick, so we can actually see what it is that I'm talking about laid out, and then we'll take a look at it again. So let's return to this one, which is kind of our rocky appearance here. And we said that these maps were used to somehow convert this smooth little shaded ball into something that looks like this rocky surface. So how did that actually happen? Because that was a pretty dramatic transformation from a smooth little ball of clay into something that actually really looks like rock. So the way that works is by use of maps, which Mike, you just mentioned a minute ago. And again, these are just image files that you can get or create. You can, create them with systems, or you can download them from the web. And these are descriptors that we can use as inputs rather than just colors and sliders. We can use color information from an image that will then all combine into an appearance that we're looking at. So if we look kind of across the list, you'll see that these are kind of the ones that we were looking at in that basic list of appearance parameters, right? These are kind of the familiar ones that we were just looking at. And those are the ones that you'll often find will be provided with a set of maps that you might download or create from somewhere. So we've got the albedo / diffuse. I listed both ways here again, just for clarity. That's just all of our color data. But our color data alone is just like putting a sticker on the model. It won't give us much more than just, now we've got extra color data. That's good, right? In our eye analogy, we've now got, a bunch more colors than whatever our resolution is. We've got that many colors as opposed to just one. That's good, but not what we need to fully make it look more realistic. So next over, we have a roughness. Now, Mike, you mentioned this as one of the most important ones. So that slider will control the roughness of our surface, just like you said, adding sandpaper. But now look at this. We've got roughness in the form of a map. So we can fine tune where on the surface it's rough or not rough. So in the case of, this little ball here, we see that all of these little cracks, the roughness has been bumped up. So all of the little areas that should be sucking up light are going to be sucking up light. And we've got some more darker tones on the surfaces of the rocks. And you can see those surfaces are kind of gleaming with light. They're smoother than they are in the cracks. So we're targeting where the roughness actually is from across the entire map, across the appearance. And that gives us a lot more control over what this actually looks like.
So it's literally mapping the location where you want more roughness or less roughness. I learned something pretty cool a while ago. The iPhone and new Androids can blur the background and you can adjust the blur.
Yes.
What that actually does is it creates an image map. So it's using the IR to figure out distances, and close distances, it'll create that same like grayscale map. And then it uses that map to then blur the pixels. It's not optically doing it all. So it's the same technology. It's totally kind of off topic, but I always thought that was interesting to map that on there. So again, this is what maps are all about. And I think this is a beautiful slide, Jesse. I'll let you continue, but this really puts it together for me.
Yeah, absolutely. And I had an app at one point that it would actually show you the point cloud of how it was doing those depth maps.
Oh, cool.
And it would actually show you the color data. But that's exactly the way that this works, right? It's just wrapping color and or more information around your model in a way that it can describe that to the shader, and then it's rendering that out.
And I'm going to ask you one question while we're kind of on a little bit of a tangent, but
Sure.
Sharn's in the audience, another awesome renderer out there. And he's got a question regarding, do you have any resources in terms of where we can get these maps? Where do you download them?
Yes. So a variety of places. So the beauty of this system is that it's very compatible with all sorts of other types of formats. Basically, any type of rendering software these days is working with a system like this. So it's exciting that we can use this with such convenience too, especially being that it's our own, proprietary system, but it still works really well with everything else. So there are a lot of places. I mean, you can literally just Google PBR appearances and it will come up with a whole bunch of different places for free. Recently, I've been using some that are paid, and we have a subscription for things that we can get. Really, the level of quality is what generally drives where you will get things. I don't have a good list of somewhere I do, but I don't have a good list. But frankly, there isn't one place that I go all the time to get the same appearances. It's usually I need an appearance that looks like XYZ. And I'll go searching for it and see if there are some free options or paid ones. If you're doing a lot of this work, especially if it's paid work or if it's something for the company, it probably makes sense to look into some of the subscription services because you've got a much wider array of appearances that are going to be a lot nicer than what you can actually build yourself. I have done some of my own. So Adobe offers tools that will let you, kind of build your own appearances. And I have done that and used those too. There's also a pretty steep learning curve to trying to make your own realistic looking one. But they've got some cool tools that are coming out. They have a tool that lets you take a photo and then it starts processing it and trying to relight it and, some AI stuff that's really exciting. That will try to convert your photographs into textures that you can then use in rendering. So that's a really bad roundabout answer of where I get stuff, but the answer is
start with Google.
Yeah, it's everywhere, really. So it's really just a matter of which type of appearance you're looking for. Start searching around for that and see where you can find it. But there are lots of free ones.
Yeah, HDR Haven, where I used to go to get a lot of scenes. That's a good place too. They have textures on there, a lot of basic ones. But
they've really been adding a lot of stuff recently. They have some models and stuff for free now too. Yeah, they've got, I think, what do they switched their name because they've got so much stuff now. Are they Polyhaven or something? But
that's right. Yeah. But
yeah,
if you search it. And then the other one was, you mentioned the Adobe. If you have a Creative Suite, the algorithmic licensing, that's an addition to the Creative Suite from Adobe, but
it is.
You can still get into they have like a basic library of PBR textures that you can download the assets. They package theirs as a SBAR file type, but you can still extract out. There's a way to get those out, but
right. Yeah. And the nice thing about this information is it's really easy to transfer, and you generally don't have to work with oddball file formats. The SBAR format you were just mentioning is kind of a unique one that you would need a software to read. But for the most part, right, we're talking about JPEGs or PNGs.
Right.
So you can download a set of images that you can use and use very quickly. So yeah, lots of resources. C00 Textures is one that you could check out.
Cool. Thanks.
Or ping me if you can't find stuff, because sometimes I'm zipping around the web looking for things. So we've got a situation now with the first two where we've got color data, and now we're fine tuning the roughness. Again, the cracks are rougher than the surfaces. This is a nice way that you can control, maybe the faces of these rocks would be rubbed down and they're smoother over time than the cracks. You're not getting any action in the cracks, so they're rougher rock, right? The next one is an interesting one. This one is metallic. It's just pure black. So this is for exactly the reason that I was just mentioning before. This is an on-off switch. Now, you wouldn't always get a metallic, but this particular texture, I downloaded this one, so you can kind of see a cross-section of what you might get. This one included it, which is kind of nice, because that way you don't have to worry about forgetting to set that setting based on what this material should be. It's just setting it for you. So it'll read in the map and it says it's on or it's off. It is metallic or it isn't. So all of those slider settings can also be set with color data.
And you can map metallic, correct?
You absolutely can. Yep. Yeah. And that would be a case where if you had something that was kind of rusty and crusty, or you've got dust on the metal or something like that, that's where you would normally see that kind of thing, where you've got something that's dielectric that's overlaid over a metallic surface, and you would say it's only not metallic visibly here, right? And then you would see some color information, not color, but you would see some variation in color, right? It'd still be a black and white image. Next over, we have the normal map. Now, this is a unique looking one. You can kind of see some like RGB kind of things going on here. This is what's telling the shader the height information of how it should pretend it should look. So you're saying, as soon as I say that, well, okay, smart guy, there's an actual height map next to it. Isn't the height map giving it the height information? That would seem obvious. Sort of. So there's two ways that you can tell the shader what to do with some geometry. You can fake it, or you can actually put some height data in there. Now, I would say the vast majority of the time I use normal maps because you generally don't need the complexity of adding in a height map. I'll explain what I mean in just a second. So the normal map itself will tell the shader how light interacts with that surface, and it will pretend as if it is actually got that height information in there. If you looked at it on an angle, it would still be totally smooth, but it would be lit as if there were cracks and divots and things in it. So, the light that's catching on these little edges of cracks and things like that, you would still see that show up. But if you were looking at this sphere up close, you wouldn't see all the little variations in the edge itself that you would get from an actual height map. So conversely, what a height map will do for you is that will actually take the geometry itself and move it and stretch it. That seems like something that you would pretty much want every time, right? Because you can make a really simple model, and then you can just pretend it's got a lot of complexity, actual physical complexity to it, by just throwing a JPEG image at it. The downside to that is that you'll need a lot of detail in the actual smooth shape to be able to have that resolution to add that detail back in. So you almost sort of need some of the detail there. It's not quite as heavy, but you need some of the detail there as fake detail, right? It's still smooth, but the detail is baked into it with your poly count. that will then get moved and stretched. So I would say normally, unless you're close up and you really need it, the normal map will probably do the trick for you. It will get the lighting trick that is enough to make it look like it's deformed without having to actually deform it.
So on the height map, if I were to do a height map and really scale that mapping up, would I start to see like shadows in there where normal
Yeah, absolutely. And you would get that with both. So let's jump back over here. Let's just remove this. We'll make another new appearance. And we'll talk about how these maps actually go in, right? So we see these maps showing up as we saw them on the list, the same naming conventions here. These little plus marks are where you would actually add that additional detail. So if we click on albedo here, we'll see this takes us to our textures folder, which we can also access through the library. And you'll see in here a bunch of stuff that looks just like what we were just looking at, right? So we see we've got these maps in here that, okay, we've got a carbon fiber one. This is our diffuse shader for that. And then next to it, we see the carbon normal. That's the normal map. So those two are associated. So you can use these maps in combination and map them to the appropriate channels. And then you can work with those as far as how they interact with the model. Now, again, as we have mentioned, the benefit of this system is that you can then also use stuff that you have pulled from the web or created yourself to be able to reference that as well. So you can see this is the downloaded one that I've been using as a reference. These are all the maps that came with that file that I downloaded. So you can see there's a whole bunch of stuff in here, some of which we might want to use and some of it we might not. So we've got some maps in here that we may or may not put in slots, but we can see some familiar ones in here, right? So we've got the diffuse. That's our albedo. We've got a height map in there. We've got a normal map in there. So some stuff that we're familiar with. This particular one has a lot of maps for a lot of different purposes. One of the things that I really love about this system, rather than just choosing one individual one here, let me pull this up in an Explorer. So once this, actually, we didn't apply this appearance in here. Once this appearance is actually applied to the model itself, you can take the maps that you have downloaded, we'll select them, drag them and drop them right onto the model. And you can see that it's doing some thinking in the background and saying, okay, I'm loading up your textures for you. Let me see what I can figure out to see what goes where. The cool thing with PBR is because it's fairly standard, the naming convention is usually pretty similar. There's a couple different ways that you can go about it. But there's actually some intelligence in the background that will adjust for that. So usually I actually can't think of a situation where I have had this not work. If it's, any kind of standard download that you're getting, this will probably do the trick. So I've just dragged and dropped that on. Now, keep in mind, some of the maps in there were not even maps, right? There was a thumbnail image and things like that. And what it did was it said, hey, I found slots for all of these things based on the name of the maps that you had downloaded in that folder. So this is typically the way that I use this. Now, once those slots are in, you can see that there's no longer that little plus mark there. We now have color information that's driving that. What was that slider? What was this slider? So all of that is now detailed and included into here. So this one had a height map, which I said I don't usually use. And we see that we actually get some deformation starting to go on there, right? It's starting to actually move the model around, even though this was just a sphere to begin with. So that's the combination of those maps, putting in that information and also deforming this. If we want to see what the maps themselves are doing, we can bump over to the texture tab, and all of their information is laid out here for us. If we click on the albedo, we can see all of the albedo information. These are all the adjustments for our color. Metallic, again, this is just one color, but we can make adjustments there. Roughness, likewise, all the way up and down the line for our normal, for our displacement.
That's really cool.
Last, you've got your text mapping, and this is how those square images are being projected onto the geometry that you have. Now you see here, this is listed out as UV. This is probably the most unusual of the situations. That's because I started with a primitive, and the primitives in Visualize are all already UV unwrapped. So it has that ability.
Hold on. I'm following you, but you got to wind up a little. We got to back up a little bit on the UV unwrap.
Yeah.
What does
So
that mean?
what that essentially is think about a piece of candy that you have. You take the wrapper off. That wrapper was flat, but wrapped around your piece of candy. That's exactly what UV unwrapping is.
I gotcha.
If you think it's going to be that easy for you, I'm afraid you're sorely mistaken. UV unwrapping is very difficult.
Yes.
It can be very difficult. And is probably, if
a box is easy, a car body is not.
Yes. Yeah. If you ask 3D artists what's the bane of their existence, UV unwrapping is probably going to be the thing that they say. It can be very tricky to wrap something that's flat onto something that is not flat, right? Because things stretch and all of that, and that gets very tricky. In this case, very straightforward, because this primitive is already UV unwrapped for us.
So
however,
the way area that, and I know we're going long on this, Sean, I apologize. Sean's in the background helping produce it, but
Screaming.
Super interesting. And we gave you the warning we were going to go long. The way that UV unwrapping made the most sense to me was, I'm not a big gamer, but I spend time in Call of Duty and those types of games, as most of us do at some point. And if you think of like a gun or anything in there, any prop that's in those, you're going to have wear in the handle. You're going to have rust in areas. You're going to have some weird discolorations that are specific to areas on that model. In order to do that, they use maps, just like Jesse's been talking about, but they'll unwrap that geometry and then they kind of paint, like saying, hey, we need metallic where there's this paint has been worn away. We need roughness where there is paint. And then that gets remapped using that UV. So that UV is telling it where those maps are going to fit. So they line up really nicely to the geometry. And that's kind of like, oh, that's, to me, was my aha moment of the UV unwrapping and rewrapping back to the models. And it's kind of that next level of kind of sophistication when it comes to creating the really, really complex renders.
Yeah, exactly. And that's the translation process between what's in 3D and we only have a 2D image to try to describe the visual data. So how do we translate that, right? That's the UV process.
Yeah. Now you're saying a great point in here on what the UV actually means. It's not ultraviolet. It's a coordinate system used to.
Yes, coordinate systems. Yep, exactly right. So at this point, you're saying, okay, well, thanks a lot. You've led me down this whole path of learning what these things are, and I can only use them with UVs, which are impossible to create. No, not necessarily, right? The reason why this shows up by default as UV is, again, because it already has a UV map set up for it. So for convenience, you're probably always going to get the best mapping by UV unwrapping it. That's usually not necessary. So if we hit this drop down, you can see how this is mapped. And here we see the things that we're familiar with, right? You may not be familiar with UV, but you're probably familiar with the rest of these projection methods. We've got some box projection. We've got some planar, spherical, radial. So essentially, we're just mapping this up with whatever's closest to the geometry that we have. In this case, of course, we have a sphere. So spherical mapping makes perfect sense here too. And that works just fine. Now, the reason why I ended up in this tab and sent us down this crazy tangent was because I wanted to mention that if you are using height maps, this displacement density is a good thing to know that it's there. Because when we added this height map, it just turned it into something that sort of looks like a deflated kickball, right? It didn't really give us what we thought we were going to get. And that is because this sphere doesn't really have a lot of information in it, right? It's just a smooth sphere. So there is a way to artificially lift the detail of your models, whatever you've got imported, to say, I actually do want to deform this with a kind of image to add more detail that I really didn't want to model, right? Try to think about modeling all of this. It would be a nightmare, really, in any type of modeling. This would be a nightmare to try to make. So we would never want to model it, or it wouldn't be practical to model it. But we might want to lift the detail of the model to try to map something in there. So we could come in and say, let's add like a 200 and apply that to the geometry. There we go.
Cool.
Okay.
At some point, I found a displacement height map, I should say, of I want to say it was the New York City skyline. And it was cool because I was able to go in and just have a flat 2D primitive and slap it on there, and then using the slider lift the skyline up, and you could see all of the, and I had another one of Mount Denali as well. I don't know where they went, but
yeah, once you start getting the understanding of how these maps work, you can really take something that's almost nothing to model and make it look like something that was really, really complex with very little effort, which is pretty cool.
Mm-hmm.
So again, in this case, we're using a height map. So we're actually getting some deformation going on there. I don't always do that, but it's something that you can do. So let's move back to the texture tab here and look at these maps again. So this is where we control and fine tune everything. We just kind of drag and drop, place this on. This might not be exactly what you want, right? Maybe that depth is too much. Let's lower this to 0.2. Okay, that looks a little bit more reasonable. Right, that those rocks shouldn't have been that deep. Again, normal, similar idea. It's just faking that lighting information. Maybe let's do some directional lighting here. Let's put in like this.
And there's that hue that you're getting, right? That coloration from the light source.
Yep. We're suddenly kind of blue looking.
Blue hour.
It's a blue hour, yep. So again, always a good idea to set your lighting, whatever your intended lighting is going to be, before you go start messing with all of these things, because it is a combination of those interactions. So if this is the HDR lighting that you really, really want, make sure you start there and then start making your adjustments from there, because that's what it's going to look like at the end.
Awesome. Hey, I got a question I want to pull up. So Akash from one of our colleagues from across the other side of the globe, awesome designer, super bright guy. Was wondering about GLTF. How does this all transfer over?
Yeah, wonderful question. And that is one of the benefits that I was going to highlight.
What is it?
So a great segue. Let me finish up what we're doing here, and then I'll mention.
I want to make sure we got to that question before
we wrap up, because that is a great question.
Because I know it's probably midnight over there for him.
Yeah, definitely. We're just about finished here. So again, any of the adjustments or tweaks that you want to make are super easy once you've got this set up, because you can just click on any one of these and start making any adjustments that it tells you can make. So for example, if I wanted this to be warmer, now that we made that lighting a little bit more blue, say, okay, maybe we'll pick one of our warmer gray swatches, and that will overlay that on there. Oops, sorry about that. And then maybe I want it a little darker or a little brighter. Let's mess with that. Yeah, okay, maybe a little brighter. I want to maybe change the hue and saturation, maybe make that a little bit more apparent, that it's a little bit warmer. Right, mess with this. So just because you imported a map, and hopefully those changes are coming across a little bit on the screen. Mm-hmm. Just because you imported a map doesn't mean you have to then go be stuck with exactly what came in. You could make those adjustments and those fine-tuning things right from within the software, rather than having to go open those in some external editing solution and try to figure out how to go and Photoshop it and then bring it back in. It's all very adjustable right from within the PBR interface. All of these little sliders and adjustments that you can make, you can fine tune an image, start with something that's pretty close, and then fine tune it in almost instantly. And the great thing is, if you are making those tweaks and you realize, I totally messed this up, you can just hit the reset button, set it back to where it started, and then, make your adjustments again. So really nice, even just things like brightness on a roughness map can be really nice. You can say, I like where this is applying it. I just want the whole thing to be a little bit more shiny, or I want the whole thing to be a little bit more dull. And you can just make those adjustments on the fly. And not have to try to use a million different softwares to figure out how to, realign all of these things.
And Jesse, in real-time rendering, right?
Right.
For me, it's so much trial and error and playing with things, especially if this is new to you. Just see what that slider does. Go to the extremes. Yep. You're going to get a feel for it, and you can balance it out over time. You kind of know where to start looking to make those tweaks and adjustments. So if you're new, this seems kind of like, whoa, this is a lot. Just get in and play with it. There was a question about training resources, and we do have them out there, but honestly, just mucking around with it, seeing how it responds is going to be a great way to learn.
Yeah, absolutely. Totally agreed. And that is one of the benefits of having the rendering going right as you're, it's a what you see is what you get rendering engine, right? So you can make those tweaks and whoop, that wasn't it. Hit the reset button and try something else. There is also a resource for PBR that is actually pretty well written that lists out what every single one of those parameters does and how to make use of it. And if there are any gotchas, if you're trying to use anisotropy and it's not doing anything, you realize, I need to have my roughness turned up or something like that. Mm-hmm. So there is a great resource for that. too that is available. One last thing I wanted to mention with the maps is that they are synced. So you'll notice that if I was making any changes to that, this little checkbox at the top, they're all synced together. So you might be wondering, okay, I've got all of these maps that all need to overlay perfectly. What happens when you go change the scaling or something like that? Don't worry about that. They're auto synced. So unless you turn the syncing off, then you will have these auto lined up for you automatically.
Nice, man.
Cool. Let us return to where we came from. I haven't even looked at the time. Are we like a million?
We're way over it. I mean, I knew we'd go long, but
you didn't know we'd go this long?
This long, yeah.
Okay. Well,
that's all right.
Apologies. Let's try to put a bow on this then. DSPBR, there's two real things that I love about this switch. And again, this system is coming to SOLIDWORKS as well. So this is good information to know because essentially everybody's going to have use of this. It has complexity, but it also has ease of use. And it's really rare that you get the two of those together. It's got tons of parameters that you can switch. When I hit the enterprise model, right, there's tons of stuff in there, more stuff than you would probably ever use. So you've got all of that detail for fine-tuning things when you really need it. But they did a great job of simplifying that down to the subtypes, so you don't have to know which ones of those apply to your particular situation for every appearance. You can use those subtypes, and then if you want to add more information to that model, use those maps. You can load in maps, and you get a lot more data there. Two is the consistency that it provides, and this is what I was talking about when we mentioned GLTF. We have consistency across all of your appearances in Visualize because they are all actually the same appearance. Once you learn one model, you can use that to make literally anything. So under the hood, it's all the same appearance model. You learn it, you can make anything with it. Consistency across all of our products is great. I mentioned that SOLIDWORKS is working on this system too. That makes translation really, really nice and seamless because you can go right from SOLIDWORKS right into Visualize. It's got all of that data. Whatever you assigned anyway in SOLIDWORKS brings that all right in. So you've got visual consistency there. If you're loading things to the platform, which we all are these days, consistency there. And we also have more consistency with exports. GLTF, as just mentioned, really popular file format. I use that quite a bit myself. This format lines up really, really well with the shaders that are in GLTF. That is not by accident. That's very intentional. There is sort of a standardization going on that seems to be happening quite well. GLTF, if you're not familiar, is sort of an intermediate format. It's like a step file, but for graphics. This lines up really, really well with those shaders. So you're going to get really nice consistency, much improved consistency, sending things out to intermediate formats that can be used for things like websites and VR and things like that. All of that just became way easier because that information will transfer very nicely. And on the import side, anything that you're buying or downloading for free, drag and drop literally. And you've got those maps imported in because it's sort of a standard way of working. So,
you know, and I'll mention too, on Visualize side, you can export those GLTF files. Yes. Those are used in kind of, you can do interactive like web or be able to rotate, move 3D in your web. PowerPoint actually supports GLTF too. So if you're ever doing a design review, you can put it in there and using a thing called morph transitions, you can actually get it to move between slides, which is really cool. It is a whole nother topic. But I also should mention that SOLIDWORKS CAD, as of last year in the 2024 release, this year, I guess, I'm always a year ahead, supports that as well. So all versions you can save out GLTF, GTB are the two kind of standards you'll see there to use on the web. So if your company that you're working for has a web initiative to get 3D on your website, take a look at that. We do support it. And as Jesse mentioned, the DSPBR appearance style is going to be coming to SOLIDWORKS in a version coming soon.
Yeah, that's a great point. So if you are using GLTF right now, I would recommend doing that through Visualize because Visualize already has the DSPBR format, so you get much better performance there. SOLIDWORKS, again, will be adopting this, so that will help things out there. But Visualize would probably be the smart way to do it. The only caveat there is PowerPoint does not accept the Draco compression for it.
Right, yeah. So you got to defeature it, get rid of the internals, try to lighten it up. Jesse and I have run into that But it's still totally doable. Like just keep in mind that PowerPoint's not not looking for large assembly. But
you can break your presentation pretty quickly.
Yeah, but it's a great way to show like a client design reviews. You want to kind of up your game there. It's an option to play with. So, Jesse, anything else? Otherwise, I'm going to wrap this up. I mean, this was super informative. You went through 3 awesome buckets. You introduced DSPBR or PBR in general, right? It is an industry standard that we are now adopting across the board for our appearance definitions. So which else is great. If you want to learn more about this and you Google it, there's tons of information. You can get all the way into the weeds on the PhDs that came up with it out of MIT and all the other folks around the world that have helped create a way for us to view or the computer to tell us how we should be viewing these models using this very simplified format. You showed us how to basically do it in Visualize, which I thought was awesome, right? Some of the basic sliders, start playing around with it, see what it does. And then you got into the advanced stuff too, without going too deep, because you can, but again, it's all what you see, what you get rendering. So playing around with those sliders, you can go ahead and great part of Visualize Pro for learning. Up there that Eric Scott, thank you, Mark, for the Makers version. So the Makers version comes with Viz Pro. That's the full-blown version of rendering. You can that's locally on your machine. You can save your stuff to the cloud. You can work locally off your machine if you don't want to connect to the cloud on the Makers version to start playing with this stuff for an insane price, $48 a year. Can't believe it. So if there's no other questions, I don't see anything else coming in. Apologize if we missed any. We try to get all of them. Hey, you know what? This has been super fun. Again, Sean, our producer in the background, thank you. We went way long, but it was well worth it, in my opinion, because Jesse is just a wealth of knowledge on this topic. Hey, make sure to like and subscribe. SOLIDWORKS Live Designs coming into you throughout the year. We're always hitting on new topics. We're bringing in the best guys out there that are in-depth knowledge experts like Jesse himself. And share this with your colleagues. Share it with your friends. You know, the more people that are liking, commenting, subscribing with our content, the more it tells us that we're doing a decent job. We're trying over here to try to bring you the best we can, and that's the best feedback we can get is those subscriptions. So we appreciate your time. And with that, we'll see you next month. Hope you guys